Okay, welcome back to worksheet solution video for relations function and functions. So here we are with part 3 of our solution video for relations and functions. So let us now go to the remaining parts of the question without any further ado. And I must have said to you, if you would like the solution video, I'm going to ask you to click on the like button. If you have not yet subscribed, please subscribe to our channel. Thank you very much. Alright, so this is where we were. Now, we're going to go to part 2 of the same question. Let's go. So let's get rid of this. Bad. Let's get rid of this one instead. Okay. Alright. Now, so part 2 of the question asks us to determine the equation of the line which is perpendicular to the line x plus y equals 3, which passes through the midpoint. But what we already know is that when the product of perpendicular lines are normally equal to -1, and of course we know what the gradient, or should I say the product of the gradients rather. Sorry about that. So let me, if I didn't say it in the video before, let me say it now. When in functions right here, the product of the gradient for when they are perpendicular is -1. If they are parallel, the gradient is equal. Alright, good. Alright, so let's get down to this one. So perpendicular means, and if the first one was -1, so it evidently means that what multiplied by -1 will give us -1, must be +1. So right there and then we know the gradient already for the perpendicular line, which is +1. Now what we need to know now is the y-intercept, which is normally the c in the equation of the line. Now they told us now that it passes through the midpoint of AB, so we have to then find the midpoint of AB. Now you could use what we call the distance formula to find the midpoint of AB, right? Or use the vector method. So if let's go back to the thing itself. So having the graph, we can use the vector method. So from here we see that. So it's 1, 2, 3. Let's check it again. So from here to here is 1, then 2, then 3. That's +3. Then coming down, 1, 2, 3. That's -3. So what we have right here then in this case is that the vector, it is 3 on the x-axis, -3 on the y-axis. So we're going to find the scalar, find half of that now. Half of that vector now would have taken us to midpoint AB. So that would have half of 3, therefore equal to 1.5 on the x-axis and -1.5 on the y-axis. So we know now what the y-intercept is, which is c, is -1.5. So because we know all of that information now, we can now write the equation of a line for the perpendicular line. Simple. So it's simply equal to 1x or x minus 1.5. So that's the answer. I preferably write it y is equal to x minus 1.5. That is the answer for that. Alright, so that's the answer for that one. Alright, so let's remove this and move on to the remaining portion of the solution video. So go to our final board, which is right here. Now it says here the function y equal x squared minus 2x minus 3 is defined in the domain where x is greater than or equal to -2 but less than or equal to 4. And you'll have seen it in the table below. That shows the corresponding values of y for the selected values of x. Now you're going to be, let me rewrite the function for you. It is x squared, so it's y equal that, good, minus 2x minus 3. Now we're going to substitute the value of 1 in this equation. So we have square of 1 minus 2 bracket 1 minus 3. So the square of 1 is 1, and negative 2 times 1 is negative 2 minus 3. So you can add these, end up with 1 minus 5. So therefore our first value is negative 4. When x is 1, y is negative 4. Write it in the table right here. Good. Then now we're going to use substitute now with 3 as x. Right? So let's now put in that information. So 3 square minus 2 bracket 3 minus 3. So we have here 9 minus 6 minus 3. So add them, add these two, negative 9 from positive 9 equal to 0. So here we have our values. Good? Alright, so the first one, when 1, when x is 1, y is negative 4. When x is positive 3, y is equal to 0. Alright, now what I need is information in the table right here. You need to pay close attention. So I hope you have taken this table down and you're going to plot with the graph. So I'm going to go back to the graph now, then I get back to that question. Alright, let's get back to the graph itself. Let's go back to the graph itself. Here's I think but it would have been part A, page 16, which would have been this graph right here. Now, so we're going to plot our points. Now, you can simply plot the points using the intercepts. So when x is negative 1, y is 0. So we could put 1 right here. Well, that's a point. Let me use a different color so you can see better. Make it more thicker. So we have x right here. Good. And then the other intercept, when x is 0, y is negative 3. Good. When x is 0, y is negative 3. So the first one, when x is negative 1, y is 0. So when x is 0 now, y is negative 3, which will be right here. So when x is 0, y is negative 3. So the next point is right there. Then now, when x is 3, we know that y is 0. When x is positive 3, that is. When x is positive 3, y is 0, which is right here. Good, right there. Now, so we're going to draw the graph using that bit of information right there. So let's draw the graph, right? Can I reduce it? Use a different color. This is blue. So draw a graph right here. Good. This is like an hyperbola. Alright. So that is the graph itself. Something looking like that. Alright. So let's go back now to the question. So we did part 2, we drew the graph. So let's say now, using the information from the graph, complete each of the following statements. The maximum value of y occurs when x is equal, the minimum value of y occurs when x is equal to what? So let's look at that now. So let's go back to the graph. Now, if you notice now, it's right here. Right here. Now, when we talk about minimum, let's draw that different. Let's draw it. If you go like this, where it's curved right here, that's the minimum. The maximum now, curve at the top. So curve at the bottom. So minimum is basically when x, the value of x, when it's maximum. Let's go back to the question quickly. So when what is the minimum value of y? Sorry, of this expression when x is equal to what? So therefore, this is the answer here. So when x is equal to 1, we'll have our minimum value. Alright, when x is equal to 1, we'll have our minimum value. And it's normal at the peak, so or when x is 0. Alright, let's put that in so you can see for yourself. So when x is 0, it's -3. But when x is 1, it's -4, which is the minimum value. -4 is less than -3, so the minimum value. Good. So the answer is when x is 1. Now the values of x for which this expression x squared minus 2x minus 3 is equal to minus x plus 3. Alright, when they're equal. Alright, let's see that. Let's see what that is. Minus x plus 3. Now this one, let's look at it. Now this is x plus 3. So we're talking about minus x plus y is equal to 3. Now, which one would this be? Which one would this be? So they want to find out where the curve intersects. Good. They have minus x plus y equal to 3. Now we could find the equation of a line right here and say y is equal to positive x plus 3. Good. And that would have been this equation right here. Well, let us, if we could plot a point, let's see where it is. Let us say that when x is 1, y is 4. So when x is 1, y is 4. So this will be this line here. Let's try that one, right? When x is 2, y is 5. Somewhere right here. When x is 0, y is 3. So we're seeing where the line is progressing in this direction. When x is -1, when x is -1, y is positive 2. Just come right here. When x is -2, then y will be positive 1. So technically, it is progressing in this direction. Right? So watch the curve now. So the curve would go consistently out. If you try it properly, the curve would go. So what the answer would be somewhere right here is that when x is -2. Right? Because if we draw it properly, this would, if we want to extend this curve, we could simply put in -2 in that equation that you have there. And if x is -2, let's see where the next point would go. That would be the square of -2 will be 4. Then 4 plus 4 is 8. 8 minus 3 is 5. So y will be 5. Right here. Good. So basically it'll be, so let us draw the line itself. Draw the line. Let's connect these two. Here's our line. So what you're going to end up, our curve now, our curve must come to this direction right here. Do you see what I'm doing? So right here. So you see what is happening here now. So it's not accurate, properly accurate though, but it would have intersected somewhere right here. So this basically would have been somewhere between 1 and -2. And I would probably say it is actually say 1.5 to -2, -1.5 to -2, somewhere there. So if it was drawn accurately, then you'd have, if you have -1.5, you give it the answer. Or if you have